Hey guys, this is Dale. I'm the guy with the 1928 Terrot motorcycle that's trying to build a bulletproof engine now to make it across the country and hopefully the Cannonball run. Um, this is the cylinder to the motor. Again, this is a 1928 Terrot. It's 350 cc's, single cylinder, 4-stroke engine. It's all one-piece head. This is the exhaust. This is the intake. This is where the carb is going to sit. We call this front and the back of the motor. This is front to back. Usually when a motor wears out, it'll wear out mostly from front to back. This one is worn out mostly side to side. So the reason for that is when I split the cases, this is a one-piece connecting rod. It's got roller bearings on the big end, and you'll notice that there's a lot of slop in that thing from side to side. There's probably like 3/16 or 1/4 of an inch in there. And what's happening is when this piston is coming up and down, that rod is able to move quite a bit back and forth, and I think that's what caused the side to side wear in that. So this is my piston for this particular bike. Now, I can get this made, but you have to get the person that I called, I had to get a certain amount of them made, and it's pretty expensive. So instead of doing that, I was over by my buddy's place, and he's rebuilding an old Harley, a 45-inch flathead, and he says, "Well, bring your piston over and let's check it out." So I did, and they are pretty similar. So what I did is I went on eBay and I picked up this piston. It's just a cheap piston. I just wanted to get just so I could do some retrofitting and stuff like that. But if you notice, they're similar in size. This is like I said, this is the 45-inch Harley piston. This is a 60 overbore, and it's about 16 thousandths of an inch bigger than my original piston, which should work out with the wear that I have in the cylinder. Now, the one thing that you probably noticed in this piston is it's only got 2 rings in it. That's because this is a total loss oil system. There's no oil ring in this thing. So what that means is when that oil on this motorcycle leaves the oil tank, it never gets recirculated. It either gets burned up in the combustion chamber or it leaves out of the bottom of the engine to a tube that this particular motorcycle, it drips on the chain. So with the Harley piston, I am going to put the 3rd ring in it. Again, I want to try to get as much power out of this thing, and maybe by not burning all that oil, it'll improve the performance, I guess you'd say. I mean, it's only 3 or 4 horsepower, but I think it might help. So, but I think what I might do is I might just run a little bit of 2-stroke oil in it just to keep this cool and to lubricate it a little bit. But the one thing, if you do notice, which I don't think you're going to see this on the camera, but I located the center of the piston pin, and I put a scratch mark on the old piston and on the new Harley piston. And if I take this, and you're probably not going to see that on the camera, but I line those up, what you should be able to see is that my old piston is like 3/16 of an inch taller than this Harley piston. So if I were to just take this piston, the Harley piston, and put it on a rod the same stroke as what I got, that would reduce the compression in this because it's going to be further down into the bore, which I don't want to do. So what we're going to do is we're going to make a new rod. We'll make a new rod for this. And I'll probably make it out of 4140 or something. I was going to make it out of aluminum because it's easier for me to machine, but I think the steel would be a much better choice. Now, when you guys are working on something like this old, what you want to do is you want to make sure that you take a lot of measurements before you take things apart. Find all your tolerances, and what I like to say is find like a baseline, I guess you'd call it, of where everything was supposed to be before you start putting in a lot of different parts to it. Because like this particular piston, this flat top piston on a regular motorcycle, it would come up to the top of the bore, top of the cylinder, and they usually don't go any higher on the flat top piston. On this particular piston, or this particular motor, this piston will actually come up out of the bore like 200 thousandths of an inch. So it was real important for me when I was looking for a piston that I had enough meat from the top of the piston to the top of the ring so I can get that thing to come up out of the top of the bore, because if you didn't have enough meat in there, what would happen is when this came up out of the bore, the cylinder could actually hook that ring and bust that ring off, and then we're in trouble. So that's probably the piston that we're going to use. So these caps, so this is a cap that goes over the top of the exhaust valve, and it's got these cooling fins on it. They're pretty beat up. I'm going to try to make one. I'm going to try to make these out of aluminum, actually, see if we can kind of pull some of the heat out of the engine. I don't know how it's going to work. It'll be an experiment because this is going to expand at a different rate than this, and these might come loose. So we'll experiment on that. But one thing I read a long time ago that the guys used to do with the flathead Fords, which is similar to this particular motor, that they used to recess the spark plug down into the head to get the electrode more down over the top of the intake valve, which would get it closer to the exhaust chamber to help with the ignition, you know, the spark of it, the explosion. So I think that's what we're going to try to do. We're going to take this and we're going to recess this thing down into the cap so I can get that electrode more down into the combustion chamber. Now, one thing you got to be careful of is you want to make sure that your valve isn't going to come up and hit the bottom of that electrode and cause a bunch of damage. So there again, before you take it apart, you want to make sure you clearance everything. So this wouldn't be a problem. This cam doesn't lift that high and there's plenty of room. So that's another performance modification, I guess you'd say, we're going to try to do on this motor. The valve train is pretty cool on this thing. And one thing I want to tell you guys is when you're doing any type of a project, which I'm sure you guys know, is, you know, put everything in a Ziploc bag, mark everything. That way, because it might take you 6 months or a year to finish a project, and you might lose or forget how all this stuff goes together. So the valve train, so you got these, I guess I call these almost like a lifter, and this rides on the cam, this lobe rides on the cam, and it brings the valves up and down. So I'll just throw this together real fast. It's kind of cool because they kind of crisscross a little bit. So that goes in there like that. Take the cam, drop the cam in there, and then these are the push rods for the motor. And it's got, here's the adjuster to adjust the slack out of the valve. These go in here, just like that, and those guides. And then as the cam rotates, it runs on those valves, or not the valves, but the well, I lost it for a word, but that's okay. You guys know what I mean. But anyway, it goes up and down, and that is what lifts the valve. The valve sits basically right on top of this adjuster, and it goes up and down, right off of this lifter. So that's pretty cool. So another thing that we're going to have to start working on are these little, I guess you'd call these the lifters. If you notice, right in here, right where the push rod rides on the lifter, they're dished in a little bit. They're worn out. So I don't think I'm going to make these. I think what we're going to do is we're going to try to make a repair. So then again, we'll take this measurement, find out what that is. Maybe we could TIG weld that a little bit, grind that to where it's supposed to be, and we'll probably have to go through a heat treating process of that because we want this to be pretty hard so it doesn't wear out again. The push rods, like I said, the adjuster here, these are broke. A couple of these, or this one's cracked actually. You can't really see it till it's tight, but we'll have to make a new one of these at least. And again, the way that the valve rides on the top of that, that's dished out a little bit too. So we'll have to fix that because that'll affect the lift of this, and it'll affect the way that the motor breathes. So the other thing is we got to work on are these valves. So the valves are shot, and I was researching online about different valves, and I came across this Ferrera Racing Components. This is an awesome company. I called this guy. I asked to talk to the tech. He called me back right away. He kept me on the phone for probably almost an hour just talking about what kind of combinations I could do and he was just in no hurry to get off the phone. What he did was he sold me these blank valves. This is 8 millimeters right here, which I'm going to have to remount my valve guides, which I'm going to use these old valve guides. There's nothing wrong with them. I'm going to ream them out to get these things to fit. But what we got to do is we got to cut these down to length. And then if you notice right here, there's a slot in this valve. And that's how the spring goes on. That's how they keep the spring on it. So I'll just throw this together just real fast so you can see it. That goes in there. Got this little bar stock. It actually goes inside the slot. And that is how that holds the spring in, just like that. So that's pretty cool. And then that rides on there, just like that, which goes onto here, which rides on the cam. So it's pretty cool. And one thing I like about the old motors is, you know, all this is exposed. So you put these valves in, you put the spring, you know, the spring goes on there like that. That's all exposed. That's what you're going to see. There is a shield that goes on here. That's what this little hole is for. You put a bolt in it, but I'm not even going to put the shield on. I want to see all this stuff working. This is cool. And that's kind of what it sounds like too when this thing is running. It's really noisy when that valve is coming and slapping that. But yeah, pretty cool. We got to cut these valves, you know, cut the 45-degree angle, which that's already on there, but we'll touch that up. And then we're going to have to cut the seats. It's going to be hard finding a cutter to go inside there. We might have to just do it with a stone. But yeah, that's it. New springs. We'll have to find somebody who's got some new springs because we aren't going to trust that. And one thing we're going to do is anything we do make for this is we're going to make like 2 and 3, you know, so in case, or I shouldn't say in case, when we break down on the road, we got a bunch of extra parts. So, but anyway, so that's that. I think we'll make another video here real quick. I'm gonna start working on this rod. Maybe I'll make like a mock-up of one out of plastic real quick, just so I can get the tolerances of this new piston just right. I'm in no hurry. I'd like to make the mock-up and then maybe build the rod off of that. So it's easier to make something out of plastic than steel right away. So, but anyway, I'll let you guys go. I appreciate you guys watching the video, and go out and get yourself an old motorcycle, tear it apart and rebuild it and make it better than new. So I'll see you next time. Thanks for watching. See ya.